So these are the three possible structures using the formula C5H12 pentane. So these are the three possible isomers. Now the main chain is different. Here the main chain has 5 carbon, here it has 4 carbon, here it has 3 carbon. So they are chain isomers. And this property is chain isomerism. Now one thing, this is called as neopentane. When you have a carbon like this, now this group, now you can have any R group here. You have C2H5, C3H7, whatever. If you have this group, this is called iso. For example, if you have to name this compound in the common nomenclature, because this compound, if you look from the right hand side, it has this group. Fine. Now altogether there are 5 carbons. So this group is there, that means it is an iso. This group is called iso. The compound having this group is called iso compounds. Now the number of carbon are 5. So the nomenclature would be as isopentane. Suppose you have to draw isohexane, then you simply have to draw this group. This group will be there, then only that compound can be an iso compound. Now this iso group already has 3 carbons. So if you have to name or draw the structure of isohexane, you have hexane will have altogether 6 carbon. 3 is already in this group, so you have to draw 3 more connected to this carbon. Fine. Because if you look from this carbon, then you have 2 division. Like 1 carbon on one side and 1 carbon on one side. So it's kind of iso structure. Iso means same, similar. Isosceles triangle is a triangle having 2 sides same. Iso means same. So they are from this carbon, the vicinity, in the vicinity you have same kind of arrangement. 1 carbon on this side, 1 carbon on this side. So this group is called an iso group. This is isopentane. This is isohexane. Fine. Now this kind of compound are called neo compounds. Neo compound will be the one which have this structure. Now this group must be there. If you have to draw neopentane, now this neo group has 4 carbon already. Pentane will have 5 carbon. You just have to add 1 carbon here. That will be neopentane. Neohexane will have 1 more carbon in addition. This will be neohexane. What we have here is this group. This is neo group. And 1 more carbon is there. So this is neopentane. This is isopentane. This is normal pentane. This you are taught actually in class 10th. But for the benefit of those who didn't study and for the benefit of those who studied and forgot, we quickly revised it. So that's about chain isomerism, and we have learned to draw the chain isomerism of pentane. You quickly do one thing, you draw the chain isomerism for butane. The way we proceeded for pentane, you proceed for butane, and you also proceed for hexane. And look how many structures you are able to draw for butane and hexane. I'm waiting, you have to do it. If you have attempted, you must have got the answer for butane as 2. And if you have exhausted all your energy, you will get 5 structures for hexane. Let's quickly see. For butane, you will have, first will be the normal structure, all the carbon in chain. This will be normal butane. I'm not drawing the carbons. I'm not drawing the hydrogens. Now, there are 4 carbon in chain. This is normal butane. And there could be an isobutane. There will be no neobutane, because neo group already have 4 carbon and there is a free bond. So the minimum carbon required for a neo compound is 5. There has to be at least 1 carbon at this position. So butane having 4 carbon will not show this neo kind of compound. Butane will have 2, normal butane and isobutane. If you're looking for hexane, you have to start with normal hexane. This is 1, okay? Now let's have a neo compound. This is 2, neo. Iso, sorry. This is isohexane. Then there will be a neohexane. 4, 5 and 6. 3. Can we have more? Now you have to have a substituent. Till now we have taken methyl. Fine. And in this carbon, in this compound, we have 1 methyl substituent. In this compound, we have 2 methyl substituent, both on the same carbon. You will get another structure if you put those 2 methyl on different carbons. So this is another structure, not similar, not same as any of the previous structure. So this is 4. Can we have more? If you think of ethyl as a substituent, then 2 carbon will go in ethyl, you have left with 4. And if you put on the first carbon, bad idea, you're going to get this. If you're going to put it on second carbon, then again it would be not a bad idea, it will be a good idea, because you're going to get a new structure in which this will be the main group and you'll be having a carbon on methyl group on the third carbon. In iso you are having a methyl group on the second carbon. So it's a new structure. So altogether you're having 5. I hope this is all that can be possible. So these are the 5 isomers possible for hexane. Fine. So these are chain isomers of hexane. Fine. Suppose the problem is like this. Let's move to IIT level. Suppose you have been asked to draw the chain isomer for cyclobutane. Now remember the definition of chain isomers. Chain isomers will have different number of carbons in the main chain. So you have to name this. The main chain is this chain. The cyclic chain is the main chain. Now it has 4 carbons in the main chain. If you have to draw a chain isomers, you need to have a different number of carbon in the main chain. So you can have this. Instead of 4, you can have 3. Now you will be left with 1 carbon and put that carbon out on the ring. So this is these two. This is very important to understand the relation between this cyclobutane and 1-methyl cyclopropane is they are chain isomers. The reason being the number of carbon in the chain, in the cyclic chain, are different. So they are chain isomers. Or they can ask you a question in style. They can ask you, there's an alkane, C5H12, and you have to draw an isomer of this alkane in which all the hydrogen atoms are similar, equivalent. For example, suppose if you have a normal form of this isomer, if you have N-pentane, CH3, CH2, CH2, CH3. Now, in this compound, all the hydrogens are not equivalent because this is 2 degree. This hydrogen, these 2 hydrogen are on 2 degree carbon. These 3 hydrogens are on a 1 degree carbon. So they are different because they are attached to different kind of carbon. So their reactivity will be different. So they are not equivalent. So you have to draw isomer of C5H12 in which the hydrogens are equivalent. So break your head over this, you draw all the possible isomers and then see in which isomer you are getting the hydrogens which are equivalent, which looks similar. I mean they are attached on same kind of hydrocarbon. So get your answer. Anyway, I'm going to give you the answer, but you should try on your own before listening to the answer. The answer would be, if you go and try for a neopentane. Now you can see they are 4-methyl and all look equivalent. They are all attached to the central carbon. So this is the isomer they are asking for. Or they can be a bit more stylish and they can ask you like this. You have N-butane and they will say that in presence of AlCl3, this N-butane rearranges, it changes to another isomer. Now they will say that which of the following could be the possible rearranged product, and they will say you isobutane, and they'll ask you in another option isobutene or 1-butene or 2-butene. So what you did, you added AlCl3 on normal butane, you got A, and which of them, A is the isomer of butane. This information is provided, this crucial information has been provided to you, and they have given 4 options. Although the question looks stylish, but actually looking at the options, you can cross out all the 3 wrong options very quickly, just based on the fact of the basic definition of isomerism, that for 2 compounds to be isomer, they need necessarily to have same molecular formula. Now, if you go by this definition, you will find that only one compound have same molecular formula as normal butane, that is isobutane, as we have drew the structure previously. Now, if you look at one butene, butene has saturation of 1 degree. So this will have 2 hydrogen less than normal butane. This cannot be isomer. Similarly, isobutene, 2 butene, 1 butene. Butenes cannot be isomer of butane. Butane is alkane. Butane is alkene. They cannot be isomer of each other because they have different molecular formula. So the only option is isobutane. So the intention was to get you familiar with a reaction that happens when you have normal butane treated with AlCl3. You have a rearrangement of this normal butane, giving you isobutane. The reason why it happens such that you will study then when you will grow up by 2, 3, 4 months maybe, and you will start studying the chemical reactions of organic chemistry. Prima facie, there could be some reason we don't know presently, but normal butane could be arranged like this, and without knowing why it can arrange, we can answer this question. So that is good enough for us.